Hi guys, welcome back to my channel. So again, we will be having a video tutorial in dynamics. So here is our item. We have a baseball thrown downward from a 50 feet tower with an initial speed of 18 feet per second. So we are asked to determine the speed at which it hits the ground and the time of travel. Okay. So first, let's have a representation. Okay. So let's say this is the tower. Okay, and this is the ball. The initial speed is 18 feet per second. Alright. And then there will come a time that it will hit the ground. So let's call that as our VF. Okay, so we are actually looking for the value of VF and also the time it takes for the ball to reach the ground. Okay, so our working formula would be VF squared is equal to VI squared plus 2a change in y. All right. So we are given the parameters for VI, yes, and then we also have the acceleration, which is the gravity. So for gravity, we're gonna be using 32.2 feet per second squared. Okay. By the way, the height of the building is given as 50 feet. All right. Okay. So we have this, and then we can solve for the final velocity. Okay, so final velocity would be the square root of, okay, so VI is 18 squared plus 2 times 32.2 and then initial height would be 50 minus 0. So we have our final velocity as computed 59.532 feet per second. Okay, next for time. Okay, so this is our answer for letter A. Next for time, we're gonna be using VF is equal to VI plus AT. Alright, so we already have the value for VF as well as for VI and the acceleration due to gravity. Alright, so therefore we can compute, let's substitute the given first. 59.532 is equivalent to 18 plus 32.2 multiplied by time. We're going to be having a value of time as 1.29 seconds. Alright, so that's it for number 1. Okay, so next we have number 2. When a train is traveling along a straight track at 2 meters per second, it begins to accelerate with this equation, 60 v raised to negative 4 meters per second squared, where v is in meters per second. Determine the velocity v and the position 3 seconds after the acceleration. Right, so our solution would be right. So we know that the formula for acceleration is dv over dt, and we are given the acceleration, okay, and we are also given the time. All right, so to solve for the velocity, we're gonna be doing manipulation of equation. So we have, okay, so dt is equivalent to dv over a, okay, and we're gonna be applying integration. Okay, wherein our dt is from 0 to 3 seconds, and our velocity would be from 2 meters per second to the final velocity. All right. Okay. So next, we're gonna apply integration. Okay. So the integral of dt is t. Okay. And then we have the values for the higher and lower boundaries. Next, for this one, okay, let me do it manually. So our formula for acceleration is given as 60 v raised to negative 4. Good. And then we can take out the constant, so it's gonna be 1 over 60 integral of, so v raised to negative 4, we're going to put it upwards or in the numerator. So it's going to be v to the 4th dv, right? And the integral of that one would be, yeah, so it's a v to the 5th power over 5. And then our limits are to the final velocity v, right? So we can actually multiply 60 and 5. We will have 1 over 60 times 5 will be 300. Alright. And then v raised to the 5th power, apply the limits. Okay, let me just write my equation here. Okay, good. Next, we apply the limits. So we're gonna be having upper minus lower, so that's 3 minus 0 is equal to 1 over 300. Okay, so we have v to the 5th power minus 2 raised to the 5th power. Okay, and then we can solve for the value of v, which is equivalent to 3.925 meters per second. Right, so that's 1. Okay, next, for the position, we can actually use ds, derivative of the position, is equivalent to v dv over a. Okay, so we have a 1 over 60 v raised to the 5th power dv. Okay, so actually it's acceleration is equal to the second derivative of s with respect to time. That's where it came from, right? So here, next, we can apply integration. Okay, and our limits are, the position b from 0 to s, that's what we're looking for. And then initial velocity would be 2, and the final velocity would be 3.925. Alright, so we need those values there so that we will know our limits. Okay, for a moment there. Right, so the integral of ds would be s, right? And the limits are s to 0 to s is equivalent to, let me take out the constant first. Alright, we're good. Okay, and v to the 5th dv. So the integral of v to the 5th is v to the 6th over 6, right? So let me just apply upper and lower here. So that's s minus 0 actually. So we have 1 over 60, alright, v to the 6th power over 6, and the limits are from 2 to 3.925. Good. And then we can actually solve for the value of s, right? So we have 60 times 6 would be 360. Okay, 1 over 360. Okay, upper minus lower, so that's 3.925 925 raised to the 6th power minus 2 raised to the 6th power, giving us a value for S as 9.98 meters. Okay, so yeah, that's it for number 2. Number 3. Okay, so from approximately what floor of a building must a car be dropped from an at rest position so that it reaches a final speed of 80.7 feet per second or 55 miles per hour when it hits the ground? Each floor is 12 feet higher than the one below it. You may want to remember this when traveling 55 miles per hour. Alright, so our solution would be we have Vf squared is equal to Vi squared plus 2a change in position. Next, our final velocity is 80.7, so that's good. Our initial velocity is 0 because it's an at rest position. And then we have acceleration 32.2 feet per second squared. Alright, so let's substitute the given parameters. And this is 0. Okay, so we have to multiply with 32.2. Okay, and our change in S. Alright, so for our change in S, we have 101.13 feet. Alright, now so we're going to solve for the number of floors. Alright, so 101.13, we're gonna divide it with 12 because each floor is equivalent to 12 feet. So we're gonna be having 8.43 floors. Okay, so therefore our final answer would be the car must be dropped from the 9th floor. Alright, so that's it for our tutorial for today. Don't forget to subscribe and hit on the notification bell so that you will be notified if we have new video tutorials. Thank you. Bye.